Hi, my name is John Kim. Call me Mr. Kim for short. I'm going to be doing a lot of things today on vectors. We're going to be doing the introduction to vectors, what it is, vector notation, how to write vector notation, the dot product, what is the dot product of vectors, magnitude of vectors, and the relationship between the dot product and magnitude and the angle between those two vectors. Okay. So what's a vector? A vector must have magnitude. Magnitude is just basically how big it is. 50 miles per hour, 100 miles per hour, 5 miles per hour, or it could be how many gallons per minute you're increasing or decreasing. This is the magnitude, how big it is. Okay. And you also have direction. So the vectors must have magnitude and direction. If I'm going 50 miles per hour, it's not a vector because I don't have the direction. I'm going south at 50 miles per hour. That's a vector because it has both direction and magnitude. And here's a vector v. One of the beauties of vector is that it has direction and it has this magnitude right here. I can transpose it. So this vector right over here is the same as that vector right over here. Significantly, if I go like this, that's minus v. Or if I double it, that's minus 2v. Okay? And we always denote vectors with arrows. I'm not going to denote it sometimes with arrows. So again, the beauty of vectors is you can move it around. If I just go like this, in this direction it's going up. Okay, kind of can't see that very well, but if I point it up in this direction right here, this is going straight across. That's a vector too as well because it has the same it has a magnitude, how big it is. This length right over here. And it's going in this direction. Okay, so if I have a vector, let's get two pens that look similar. This vector v right here is the same thing as that vector v right here because it's actually going in the same direction and it has the same magnitude. So you can move vectors around. Like I said, the beauties of vectors. We denote it several different ways. Let's use a pen for this. When you have a vector in the xy plane, in this direction, we call that the I direction. We call this the j direction. I comes before j, x comes before y. So let's see an example one, okay, of how to do this. You have to point at the origin, and it's going through 3, 4. Oh, one of the things about vectors, it has to have a tail. That's your tail, like in the arrow, the quiver portion. So it has to have a quiver right here. And then it has to have a head. That's your head, that's your tail. So let's draw this out, see what it looks like. So this is your tail, this is your head. That's your y direction, y, and that's your x direction. Starting at 0, 0, you're going 1, 2, 3 to the right, and up 4, and that's your head. So we draw that little arrow, and it's going in that direction, northeast. And the vector, the way we denote it, is we can denote it several different ways. It's 3i and then 4j. So the vector, let's call this vector v. Vector v is equal to 3i plus 4j. That's how we write it. Another way we can denote vectors is without the i's and j's. We use like a less than symbol, 3, 4. And we use a greater symbol right over here. That's how we denote vectors as well. Most books will use this notation, or 3i plus 4j. So, I believe that's the answer. Yeah, the answer is right over here. or this way as well. There's your two vectors. Okay. How do you find the magnitude of this vector? This would be example number 2. So let's do page number 2 a little bit, and let's see how it works out. Example number 2. You have a vector A, a vector V. We're going to call it 6i plus 8j. So that's in the x direction, and that's in the y direction. The magnitude of the vector V, we use absolute value symbol as the square root of a squared plus b squared. This is the formula. You're going to see this again and again, so I'm going to highlight it. This is pretty important stuff. It is the Pythagorean theorem. Let's see how this is the Pythagorean theorem. So we draw it out first, and the intuition will come by a little bit. 1, 2, 3, 4, 5, 6 right there. That's your 6 in the I direction or the x direction. And then 1, 2, 3, 4, 5, 6, 7, 8. And that's going to be in your y direction, 8j. We start off at the origin, which is 0, 0. And that's your vector v. Notice, why did they use the absolute value symbol? Right over here. Well, the reason why most teachers don't know why they use the absolute value symbol, or half the teachers don't anyways. Here's the reason why they use the absolute value symbol. Absolute value, by definition, is the distance from 0 to that number. So the absolute value of that number is the distance from 0 to here, and that's why they call that distance, okay? Or the magnitude in our case, because it's a vector. So let's just work it out. Magnitude of vector v is equal to the square root of 6 squared plus 8 squared. That's equal to the square root of 36 plus 64, which is equal to the square root of 100, which is equal to 10. This is a multiple of the 3, 4, 5 Pythagorean triple. If I multiply by 2, I get 6, I get 8, I get 10. And that's the reason why it's a little fast, because I remember that it's a 3, 4, 5. Don't forget the 3, 4, 5 Pythagorean triples is going to be coming out, as you've seen, or the multiples of it. It's a very common Pythagorean triple. Part B now. Oh, that's our answer right over here, 10. Part B says the vector W looks like this. Sometimes books will use, instead of using arrows on top, they will use something a little bit different. They use bolded numbers, and bolded numbers mean, bolded letters means vectors too as well. So let's look at vector W, which is going to be 5 and negative 12. Remember, as I said earlier, they can use this notation. It means the same thing as 5i minus 12j. We're just going to draw it out. We can draw it out 5 and negative 12. We're going to draw it out this way. So here's your x direction, your y direction. It's going to go 5 in the x direction and minus 12 in the y direction. And that's 5. And we're trying to find the magnitude of that vector W, question mark, okay? And so there it is right there. You can use the Pythagorean theorem. Magnitude of vector W is equal to square root of a squared plus b squared. That's our a, that's our b. Square root of 25 plus 12 squared is 144. It's equal to the square root of 169, and that becomes 13. That's our answer. Make sure you, again, memorize this formula as Pythagorean theorem, and that's how you find the magnitude. Okay. We can add and subtract vectors if you want. I'm not going to denote it using the graphing method. We're actually going to use just the regular method, which is by mathematical method. Let's say, for instance, vector u is equal to 6i plus 2j, and vector v is equal to negative 3i plus 5j. I want to figure out what the vector u plus v looks like. So we just add them up. Here, we're going to add up our i's, which becomes 6i minus 3i, which is 3i right here. 2j plus 5j is going to be plus 7j. That's pretty easy. You can also do vector u minus vector v. I should put these right here. That's going to be 6i minus negative 3i plus 2j minus 5j. Notice I add like terms. Vector u minus v, which would be 6 plus 3, which is 9i, and then minus 2j minus 5j is minus 3j. And most books, if you want to look at it, it's not that hard to figure out in terms of how the vectors are being added or subtracted. I can also do something else. If I have 3 times the vector v, whatever that vector looks like, I multiply by 3 times a scalar. They call that a scalar, which is 3. So it's 3 times this vector. It's going to be 3 times, I'm going to put notation, short notation here. Negative 3 comma 5. So that's a short notation. I multiply straight across. Inside, distribute that out. That becomes vector negative 9 and 15. And you can kind of see how that works if you draw it in a graph, and it's going to be 3 times this vector v. I'm going to do some more examples for you. Make sure you understand how to add, subtract vectors. So one of the examples that they give you, example 4, in this case, is going to be let vector u equal 5i minus 3j. Let vector v equal negative 6i plus 4j. And part 1, A says find the vector 4u plus 5v. Okay. How do we do that? We multiply 4 times the u vector, which is, I'm going to use short notation, 5 comma negative 3 plus 5 times this vector, which is negative 6 and 4. I distribute that out. I get 20 minus 12, that's your vector, plus this vector is going to be, distribute that out, negative 30 and 20. So when I add vectors in this situation, I'm just going to add the x's and then add the y's. Going out of ink here, that's equal to 20 minus 30 is going to be negative 10, and negative 12 plus 20 is going to be 8. And there it is. Okay. So it's going to be negative 10i, negative 10, or write it this way, negative 10i plus 8j. Same answer. Again, this is going to be negative 10 in the x direction, this way, x direction, negative 8 units.